Hello everyone again. Thank you for joining us today. My name is Dmitrii Ivashchenko and I'm a software engineer at My.GAMES. And in this session, we'll talk about Vue classes in Unity UI. And let me briefly tell you what I do. I've been making video games for over a decade now, and I started with development browsing and some Flash games, then switched to Cocos 2D engine, and later started developing games on Unity. We have released many browser MMORPGs like Legacy of Dragons. We also produce some clicker games developing using Lua language and the Cocos creator, and many Unity projects like Evolution, Battle for Utopia, and our latest hit, Rush Royale. Let's discuss the primary methods of organizing layout in Unity UI and consider the state-based UI development. We'll touch on some issues of reducing the amount of code, generating API and documentation for prefabs. And in order to have a more productive session, let's outline the scope of our conversation today. We can find different architectures and patterns in different projects, and certain projects may be rooted on MVP or maybe MVVM, or it could even be designed around the principles of clean architecture. But in any case, we always have a bundle of a money behavior successor and the prefab it resides on and interacts with. And at this level, we usually deal with changing sprites, localizing some text, changing the appearance of screens depending on different situations, and maybe playing some animations, getting user input, and so on. In our case, to manage all these elements right from the code, we make use of component which is situated on the prefab itself, and this precise combination is our focal point for this discussion. When starting to discuss this topic, it's necessary to realize that first of all, we will talk about Unity UI, and we cannot fail to mention another existing solution in this area, of course, known as a UI toolkit. And this alternative has relies on heavily standard common web techniques that you may already be familiar with. But despite the fact that it's 2023 and the UI toolkit has been around in use for some time, it's not still not the preferred option for creating user interface at runtime. According to Unity's documentation, they still recommend using Unity UI. Yeah. Now let's look at the offerings that Unity provides us out of the box at this level. And the first one is, of course, serialized field. Everyone is familiar with this approach. When you open any tutorial on the internet, you immediately get here. And what's prepared for us here? Yeah, we create an inheritor of money behavior, serialized field are added in this class, and draw any reference to internal game objects into these fields. And that's how it works. From the code, we control colors, object positions, animations, sounds, and anything else. And what's interesting about the solution, yeah? The fact that over time, these Vue classes based on money behavior start to grow continuously. And the more functionality we need, the more we need references. The more we need something to change in our UI, something to move, something to hide and show. And for this, we need more and more links. It becomes difficult to navigate and understand these links. It's difficult to maintain their proper naming so that it's obvious what is responsible for what. So we end up with a solution that as efficient as possible, but it's much more efficient than anyone will ever notice. And at the same time, is the most labor-intensive. Implementation of any change in the user interface built in this way is done only by a programmer. And programmers' tasks have expected and known costs because they have to be reviewed, merge conflict have to be solved, and tests have to be covered. That's the whole set of related tasks. And in the end, we get such some expensive, maybe long, but very efficient solution. Yeah, an additional system that came across in various projects can be called as all-powerful animator. It configured quite simply. We have a root of our prefab, and we augmented it with an animator controller. In this controller, we create a unique graph. This graph, combined with animation, drives our user interface. And it controls many elements such as text placement, button color changes, position of different elements. And it's essentially a way of organizing our layout. And at this time in Animator, we need to create several variables, and it can be triggers, some Boolean values, maybe integers, maybe floats. And programmers have access to these parameters. They can change them at the right moments. It will affect the controller, which in turn will change our user interface. Customizing the solution is easy enough because we use only Unity's built-in toolkit, and it's quite easy process. However, as time goes on, we start to discover potential problems. The first animator supported window appears, followed by a second, then a third, and we discover one day maybe 5 active screens, each controlling different animator in each frame, and we may notice a gradual decrease in the frames per second rate. So this solution is really fast to configure and inexpensive, but unfortunately, it's not efficient enough in terms of performance. And another alternative is to utilize the conventional animation component. With this method, you can control the actions of prefab without having to use the animator. This is how performance optimization is achieved. Along with the prefab, programmers are provided with a package of animation files to be used at a particular point in time. And using the standard tool provided by Unity, making modifications become user-friendly and swiftly done. But naturally, the principal downside of this approach is not avoidable. It is the challenge of altering the animated prefab. In the animation timeline, all changes are committed based on the location of the game object in the prefab hierarchy, as well as the names of the elements. And as soon as you change the name of one of key game object or its position in hierarchy, your animation breaks. And particularly if the modification impacts a state that is seldom used, this type of error can be easily overlooked. The next is data binding. The principle of data binding is interesting and advanced technique software development. It's important to know that it's not a built-in solution, so using it will require evolving third-party libraries or creating your own. And the main purpose of using data binding strategy is to establish a clear separation between logic, data, and visualization. This separation is important not only for integrity of the project, but also for adapting the visual component without interfering the business logic. And this task is solved by implementing the model view model architectural pattern. Schemas become widespread in numerous frameworks. This strategy is based on a special mechanism that creates a bridge for data exchange between the view and view model. View model acts as an intermediate structure between the view and the application logic. And despite all the advantages of this approach, it has its own disadvantages. Although it is beneficial for large projects, it requires initial training, and it's very difficult to debug sometimes. In addition, using data binding can become unexpectedly complex and redundant, especially in situations when you need to quickly prototype a new idea for testing or evaluation. Yeah, and now we've highlighted some problems from out-of-the-box solutions, and let's move on to stateful UI. And first of all, what it is. Like many libraries, this one was born out from a pet project. And I was looking for ways to separate layouts and the implementation, but still maintain a robust format of interaction between these components. Then my team and I tried it out in production, and everyone liked it. And we decided that it was worth releasing to open source and at some point. So what the library is, at the heart of the library is the stateful component. It's added to the root of the prefab of our screen, and it contains named references to all elements that we are interested in from the code. And the link contains a field with an object as well as a role. A role is an ordinary enum from the point of view of the code, but we generate it automatically. Elements don't need to be added to this enum manually. All these processes and adjustments can be widely controlled and executed from the inspector. And the hash code from the string that with the role name is used as a value. It allows us not to overlap and merging. In a situation where someone else creates a new role within our branch at the same time as you, merging these changes become relatively more manageable. And stateful component aims to cover all user input and output. It collects all references to buttons, some texts, maybe images, animators, and any other elements. Anything we would like to use from code. And each link comes with its own role. And as a result, we get a complete markup of all elements inside our prefab. And then having references to all these objects, we can access them from code using just one reference to our stateful component. Yeah, the example shows how we refer a text. You can see that view is our stateful component. We have a title role, and we set the text for it. At this point, this list of the UI elements on the right is supported. It includes buttons, images, text inputs, drop-downs, and so on. And this list can be extended. And for what is not supported at the moment, there are separate abstract type object, which is just a reference to game object. You can get any component of them later. However, the correct approach is to expand the list of available types, of course. And the library already implements a large number of getters and setters for each type of supported UI elements. For example, get button, get toggle, get slider, and so on. And there are also setters. For instance, in the example screen class, we set the value of hours, minutes, and seconds in the timer, and then we set image with the role of user avatar. The library can either use the path in the resources of image or regular sprite. And in the example, you can see how buttons with specific roles are fetched and how event listeners are added to them. In this case, you can either use a reference to a stateful component, but alternatively, you also have a choice to construct an inheritor class stemming from stateful view. In doing so, an automatic reference to the stateful component will be gained by the inheritor class. It will also have a set of methods of the same name for quick access to them. And now let's talk about text and localization. This step is a bit different from others because there is more information here. And we support working with localization stateful component, but we have not included any localization engine in the library. This means that when using the library, you can adopt any custom localization system, whether it's based on Google tables or maybe your custom backend solution. And this can be done easily by implementing a very simple interface. And localization key may be noticed in the code column. And you can also notice the localize column. It's responsible for the necessity of localization because not all texts are interesting for us from the localization point of view. For example, player level and player name are not subjects to localization. All the rest are marked with a localized checkbox. We come up with a localization key, and then implementing one simple interface, we get a translation. Marked codes together with these values can be taken to the clipboard using the copy localization button and immediately passed into Google table, for example. Now, let's dive a bit into the detail of internal components. So far, we've considered stateful component as a component on the root of the prefab. However, it's important to know that it's not always the case. There are times when we desire to use some elements of our prefab repeatedly. And for this purpose, we have made support for internal components. Take, for example, as can be seen at the image, our example screen incorporates two additional components. There are the header and the footer. In the section inner comps, we have established links directed to these internal components. The links are also named header and footer, for clarity. And header and footer themselves can be nested prefabs and can be reused in other windows. Upon successfully marking up our internal components, it becomes available for usage within the code. We can get the component using the get inner component API method. All they need is role name and all. Now we can access our internal view, which we can interact with using the exactly same methods. Now let's talk about containers. Internal components is the way to do static markup, but we often need to add content dynamically, for example, lists of different objects, And containers are handy tools for this exact purpose. Containers work in tandem with container view component. It's a small component in which you can put a reference to a prefab and specify the route where this prefab will be instantiated. Each container has its own role, of course. In this innovation, you can see two containers, the player container for leaderboard and the stars container for stars at the bottom of the screen. After configuring the containers, you can add and remove objects directly from the inspector. This is useful when we need to test the adaptability of our user interface to different screen sizes, as well as to make sure that our UI behaves correctly when overflowing. Once we've made sure that our UI behaves as expected, we move on to the code. And the right side shows how we can fill the container with items using fill these items method. You can pass in a collection and a method that will be called for each item in the collection and its own view. In addition, we can use some methods like add instance and add stateful component to manually control the process of adding objects. So by default, we use simple object.instantiate method to create new instances. But if you're not satisfied with this method, you can override this behavior, for example, to instantiate using your DI container, like Zenject, So far, we've talked mostly about markup, but in this library, much more attention is paid to user interface states. Let's understand what we will call states here. Let's consider this example, these two screens. On the left, we have reward screen, and on the right, the card screen. On our reward screen, there are multiple states or stage or situations present. Let's say the first state, intro, will display chest. The second state, reward, will show animated appearance of the reward from this chest. And the final state, summary, we will summarize and display the total number of rewards that have been given out so far. There are these three configurations within the same window we will call states. And it's a different situation of your screen, of your window. And now let's take a look at the right, the card screen window. In the left state, we can improve our card. Here, the button is green, the characteristics are highlighted, and in the left state, we can't improve the card. The button is gray, and the characteristics are dim, and these two states can be labeled as upgradable and locked. So let's see how it's implemented. Each state is a named set of changes in the prefab. Every individual change can be considered as an instruction. These instructions may include various operations, such as turning an object on and off, changing sprite, changing the position of objects, starting an animation sequence, starting a sound effect, and many more. The more types supported, the more convenient it for us to work with our user interface. We gather all these various changes into a specific set, and this set is something we've named description. Let's take a look at what description includes. On each state, there is a test button. Upon clicking this button, it triggers the corresponding state into activation. You can see at a glance what the state looks like, how it changes the layout, and how it fits these other states. And all of this happens in edit mode. We've even learned how to play animations in this mode. And with a full set of customized states in place, we move on to the code. The most commonly used and simple state function is to turn objects on and off. To do this, just select the game object type, then drag the desired object into the field and specify whether to turn it on or off. Next is image. In state description, you can control many parameters of image objects. In addition to turning rendering on and off, setting specific sprites, you can set a specific color, for example, or material. You can also set material parameters from the state. In this case, a separate instance of the material will be created, allowing you to apply spot effect to a specific image. The figure on the right shows how the frame sprite around the character changes when switching between common, rare, epic, and legend states. In addition, you can control any text parameters. You can replace text with any localization key. You can control the size and the position of the text. You can change the color and font of the text. Yeah. And the example on the right shows how the content of the text item change at the same time and as its color. In the state settings, there are a wide range of tools for working with rect transform. Here you can set any object positioning, dimensions, any constraints, so you can fully control and customize your rects. And the animation on the right shows how the position and rotation of our tooltip arrow changes. This way we adapted it to display tooltips to elements located anywhere in the screen. Also, you can control the canvas group properties. You can change the alpha and the interactable parameters. This is useful when you want to add a state that blocks user input or disable rendering of some UI elements. Such customization provides flexibility to our user interface. And states is also a good place to customize animations. You can run one or more animations at the same time. You can stop animations from the state. And you don't have to go into play mode to test the state with customized animations. We supported sampling animation frames in the editor coroutine. So you just need to click test button to preview the animation in edit mode. No animation or animator component used to start the animation, but the animation clips themselves are needed, yeah, on lead. And the animation has the ability to use some events, and we supported this feature as well. On the right, you can see how we use state to stop all animations on the prefab and replay the animation of getting level and idle. And of course, any animator manipulations are supported. From the one state, you can set the necessary parameters to several animators at once. It makes them more detailed and convenient for use. It supports working with triggers, setting bools, integers, and float values. But in general, animator support is implemented to overlay a set of ready-made animations, controlled by animator in some existing screens. You should use animator only in rare cases when it comes to some complex animations, some maybe blendings and layers. In all other cases, it's sufficient to use a pure animation for it. Along with support for internal components and stateful component nesting, we implemented support for activating desired states in internal components. You can have small customizable prefabs on which to build a large complex user interface. Here we impose only one reasonable restriction. Only child objects with any level of nesting can be managed from the parent object. In this case, the states of the end screen will control the states of the internal components. In the example on the right, you can notice the simultaneous change in text about rarity and the border around the character image. In fact, the entire character cell is a separate card view prefab with customizable states, and it's reused across multiple screens in a project. And the purchase confirmation window states change only the text and apply the desired state to the card view. We support other types of elements as well. You can control the clickability of buttons using UI states. You can manage change material or any graphic elements. You can change the configuration of the layout element. For input field, you can control the interactable property. There is an option to regulate the functionality of entire game object or its individual components. Presently, we supported most common element types along with the most frequent modifications related to them. And one of our goals for next version is to support all the user input and output elements and all types of interactions with them. Another goal is for the next version is full support for sounds through states. Plain sounds and stopping them will be available, and this feature is already available in one of our projects, but it's a project-specific solution, and in the near future we'll release a universal solution that can be integrated with any sound system. Along with named states, you can configure an init state to be applied each time on the onEnable method is called. Typically, a reset of the screen to the initial state is configured here, and so you can always expect that user interface will be in certain state when it's opened, to which the following modification can be applied. It's also a good place to set up the opening animation of the game screen and maybe play some sounds of its appearance. From the code perspective, applying a state is some is called an API method with a role specification. This approach allows us to significantly reduce the amount of code of our view classes. We no longer need to move elements manually, change any colors, texts, sprites. All these used to be done from code, and it was very long and cumbersome. We had wait to compilation every time after adding fields. We often lost the links on the prefabs. But now with customized states, we know exactly what they work, and we can just apply the desired state by its name. In this example, we changed the color scheme depending on the time of the day. It's a small artificial example just for clarity. Now, we should mention one more feature of the library. In fact, it's very convenient to use states. However, when there are more states over time, we have another problem. First of all, maintaining a large list of states is not very convenient. For a complex window, we had a number of states increased to 50. And a long list of states is not convenient for perceive. And secondly, over time, there appear states that make sense only in the context of some other states. And to solve this problem, Stateful UI has another tool, the state tree. It can be accessed by clicking state tree editor button on the states tab. Yeah, for example, we have on the left, we have a box with our rewards, and tree center states, money, emoji, and cards are all dependent on the reward state. The reward state plays an animation of chest bouncing, and internal states themselves only change the type of picture that comes out from the chest. The money state appears coins, and the other use emoji or a card. Yeah, we also have two other states, intro and results, which are responsible for appearance of the chest and the display of the summary page. The money emoji and card states only make sense in the context of the reward state, and the intro and result states have no dependencies. On the right is a code snippet that describes the behavior of awarding rewards. This code a bit simplified just for clarity, but in real projects, it's not much bigger. Here we can see how such a complex UI behavior on the left is implemented by such small and clear code on the right. The intro state is applied in the show intro method. Next, depending on the type of reward, we call one of three states, cards, emoji, or money. And in show results method, we show the result state and populate the total reward container with the final rewards. And in this way, state tree helps us organize the states into a dependency tree. We can pass only the necessary states to programmers, hide all other technical states, optional states, and greatly simplify the understanding of our user interface. Here we can see another example of using state tree. The states at the top part, we have mainly technical functionalities. They aren't used by programmers. This includes resetting states, turning pictures on and off, visibility of state entities like chests, and some text positioning. After state at the bottom, states at the bottom are functional, and they combine some of the technical states to produce the desired bubble appearance. And when any state is activated, all of its parent states are applied in a chain. Here I just wanted to show our latest state tree. As the project progresses, individual screens get more and more states that take their place in this structure. Programmers are usually only provided with leaves of this tree. All the internal states are technical, and they are needed mostly for reduced duplication of the state descriptions. And thanks to the documentation, we managed to keep the structure up to date. We'll talk about it in a few slides. And to make it even better, we added APIs and documentation. In each individual tab of the state component, you'll find options such as copy API button and copy docs button. The first one will copy the code fragment to the clipboard. Here we will get the generated code to access all named links and states. And each API call will be accompanied by a comment if one has been prepared. And the copy docs button will copy the description of our user interface in Markdown format to the clipboard. Next to each role, there is a button with a pencil icon. By clicking it, we can write a comment about why this role is needed, and under what condition it should be used. The comment will be saved directly on the prefab, and the documentation can be put in your knowledge base, for example, in Confluence, and the code can be used right away. It's quite convenient for day-to-day use, keeping together the markup, the API, and the code documentation under version control. So let's summarize the result. What we get using stateful UI. First of all, it's the markup of all elements inside the prefab. This advantage allows us to organize our user interface in a same streamlined manner. You know what to expect in a new prefab that our colleague made. You don't have unnecessary references to objects, and what's required is just single reference to stateful component, and it allowing us to access all the elements that have been marked up within the UI. The second place, we get the stateful component and state tree tool. This powerful tool is instrumental and in massively reducing the amount of code within the view classes. It efficiently handles most tasks related to modifying prefabs. The generation of documentation APIs should be highlighted in the same way, because in fact, when we generate documentation for our user interface, we may find that doing user interface and code for it can be done in parallel. We use this library in different development team configurations. Some teams had dedicated UI developers who did only prefabs, and in other teams, all the programmers were involved in layout as well. And the library suited both of them perfectly. The project roadmap includes the following items. First of all, since we have full markup for each button, text, and any UI elements, it's possible to organize a test system that will be available to interact with user interface in the same way as we do it from the code. It will be able to click buttons to enter some text into text inputs, maybe read some content of text blocks and check it. Secondly, since we have full markup, we can create scripts for a tutorial system. This can be scriptable object-based resources containing sets of instructions. And an example of instruction might be a show pointer at some button with role upgrade, for example. Yeah, and another desirable addition is to increase the number of supported elements and cover all the possible ways of interacting with them. So finally, I just want to say thank you for your attention, and also thank you to JetBrains for hosting me. If you enjoyed this, and if you want more, I suggest you to go out the project's repository. And thank you very much for having me today. Again, if you have any questions, feel free to email me and contact me to ask you questions. Yeah, thank you very much.
Yeah, thank you very much. That was very impressive.
Yeah, thanks, Dmitrii. Yeah, there's a lot of good feedback in the chat there. Lots of people very interested in this. The state trees, for example, they look really, really useful. They look like you can build something, very nicely reusable and complex, and yet with a nice user interface for the API and everything. Yeah, it looks really cool.
Yeah, and I spotted some nice comments because we have some people who are just starting with the game development. They say that they're not game developers right now, that they're just interested in the technology. So looks like you inspired them. That's good. Okay, so let's go to questions.
Yeah, the first question really is, how do you add it to your own project there? So we can see it's on GitHub, but sort of what does it come as, and how do you add it? Is it available as a package, for example?
Yeah, it's a Unity package right now. We didn't publish it in Asset Store yet. You just need to get this package, unzip it, and there will some generated classes have to be appeared in your project, and you can immediately use stateful component in your new prefabs. You can also have some existing prefabs and try to remake it for stateful view. but of course it'll need you some time to put on it.
And is it easy enough to add into an existing project, rather than having to start from scratch with stateful UI?
You don't need any additional steps to adapt existing projects to stateful UI. You can immediately start making new prefabs using this library, and if you want, over time, you can adapt some of your old interfaces to stateful UIs. This almost it will reduce the amount of your code, but it also will take some time.
Sure. In fact, somebody asked. They mentioned that one of the original challenges was the usage of programmer bandwidth and the time it takes to sort of implement the UI there. Has the library sort of succeeded in that? Has it reduced the amount of time for building the UI implementation?
Yeah, you don't need to add any serialized fields in your view classes. You don't need to wait any kind of recompilation for this operation. You don't need to maintain the links because all the links contained in this stateful component object, and you just need to have the link to this stateful component and use the roles and states inside it. Yeah, so you can at the same time configure your prefab, your stateful component, and write some code without any recompilation. It's fast enough, yeah.
And it looks as well that you can do some. You can get non-developers, non-coders to actually add to your states there as well, which makes that more useful.
Yeah, it was the first purpose because we tried to make the prefabs without any programmers.
Great. We've got a bit of a follow-up on the installing it, adding it to your project there. Is it just as simple as downloading the zip from GitHub, and do you then re-import that as a custom package, or do you put it in your packages folder, or quite, is it just as simple?
Right now, it's just a Unity package from the GitHub, and just download it and import it in project.
Import into project, so it would live under assets then.
Yes, it's in the plugins folder. Yeah, in the assets.
Yeah. Cool. Thank you.
Yeah, sounds good. Yeah, so there was actually a question regarding the like more maybe in depth about how do you manage different UI states which have different duration. So like what if they switch the state while the previous one is still running? How is it done? So can you comment on that?
Yeah, that's a good question. We tried several implementation options, and in one of them, we made applying states as a long process. And each next state in the tree was applied only after all animations on the previous state were completed. But it turned out to not so convenient, and almost nobody used it. In the end, we settled the implementation where the state is applied instantly, but the set state method will return you the time. Time will be in seconds, and if there are no animations in the state, it will be 0. But if there are multiple animations in the state, we'll return the time of the longest animation. So we can, I don't know, use your coroutine to react for the state was applied.
Okay, got it. Thank you. Matt, do we have some more?
Yeah, we've got another question then asking about a container view. So can the container view do object pooling for the view prefabs?
It's a now desired tool feature for our library, because right now it's not has any pooling, because it's just an instantiation of the prefab, and there are no methods to delete it, to remove it from the project hierarchy. But in our project, we has integration with some other libraries which has object reusing, and it third-party library. We can't include it in this solution, but in future versions, we will implement our own solution for these kind of tasks. Yeah, of course, we will have pooling.
Yeah, as it's up on GitHub there, are you sort of fully open source and taking pull requests as well?
Yeah, it's fully open sourced, and I am welcome to contribute and give any feedback about it.
Fantastic. Yeah, sounds good. I think we're going to have to share the link to GitHub again. We'll add that into the chat.
Yeah.
on YouTube.
Absolutely, for sure. Yeah, thank you very much. That was really impressive, very insightful, and I guess useful for many of those who are like for a longer time in game development, who are just starting. Like everyone found that very insightful. So thank you very much. Yeah, and
Thank
yeah,
you.
have a good day.
Thank you very much.